Welcome back to The Explainer. Okay, today we are going on an absolutely incredible journey. It's one that starts in the dusty depths of ancient history and zooms all the way into the staggering complexity of microscopic biology. We're going to explore a mystery of the natural world that has completely baffled historians and excited modern scientists alike. We'll be looking at all of this as a profound reflection on nature's design and its hidden intelligence. And I promise you, by the end of our time together today, you might just look at an everyday object sitting in your pantry right now in an entirely different light.
So let's kick things off with a pretty staggering number. 3,000? When archaeologists first began opening those ancient long-sealed tombs in Egypt, they obviously made a lot of world-changing discoveries, but scattered among the gold and the artifacts, they found something completely unexpected. Jars of honey. Honey that was over 3,000 years old. But here's the truly jaw-dropping part. It was perfectly preserved. We're not talking about some petrified, fossilized rock here. This was edible food from millennia ago. Think about that for just a second. This substance was harvested and sealed thousands of years before modern refrigeration, way before artificial preservatives, and it hasn't spoiled at all. You could literally spread it on toast today. Obviously, this ancient anomaly caught the attention of modern science.
Which brings us to our first section, the medical paradox.
So when researchers actually started breaking down the nutritional and chemical profile of this immortal food, they found something that completely flips our standard understanding of nutrition upside down. Look at this biological reality. Honey is roughly 80% sugar. Now, normally, a substance this dense in sugar would be an absolute metabolic nightmare, right? But incredibly, data from 18 clinical trials involving over 1,000 participants shows that it actually improves blood sugar and lowers cholesterol. It actively reduces cardiometabolic risks. How in the world does an 80% sugar substance do the exact opposite of what we expect sugar to do?
Well, the answer really lies in its sheer complexity. Just listen to this quote from Dr. Tusif Khan over at the University of Toronto, published in Nutrition Reviews in 2022. He says, honey is a complex composition of common and rare sugars, proteins, organic acids, and other highly likely beneficial bioactive compounds. This proves we aren't just dealing with a simple natural sweetener here. We're looking at a highly complex, meticulously crafted chemical mixture.
And the medical marvels absolutely do not stop at metabolism. Building on this, Dr. Joel Yupanqui-Miles and his team at Manchester University published research in 2022 uncovering some astonishing tissue-regenerating properties. This substance effectively treats burns, it heals chronic wounds, and it acts as a really powerful antimicrobial agent. It is essentially natural medicine.
Which naturally forces us to pivot from the what to the how. We know it survives for 3,000 years, and we know it heals human tissue. But why? Why doesn't it spoil? Why is it that bacteria, the exact organisms that break down virtually every other organic substance on planet Earth, simply cannot survive inside of it? Well, it turns out this indestructible superfood relies on 3 distinct chemical pillars to create a completely inhospitable environment for any spoiling agents. Number 1, high acidity. Number 2, a uniquely thick consistency that totally deprives microbes of the moisture they need to survive. And number 3, hydrogen peroxide.
Let's zoom in on that third pillar for just a second. According to 2012 scientific research, hydrogen peroxide is quite literally one of the deadliest substances to bacteria known to science. Its presence inside this sweet nectar acts as a fatal roadblock for any microscopic invader that's hoping to cause decay.
But wait a minute, right? Think about this logically. Flowers do not produce hydrogen peroxide. Pure nectar doesn't contain it. So where exactly does the hydrogen peroxide come from? To answer that, we have to zoom out from the chemistry lab and actually look at the source. We have to enter the realm of the hive itself, to look at the microscopic chemical engineering performed by the bees, and I promise you, it is nothing short of mind-blowing.
And that leads us right into Section 2, Nature's Master Engineers.
This is where we see a highly sequential, deeply engineered chemical procedure. Dr. Milas and his colleagues mapped out exactly how this happens. Step 1. The bee actively secretes a specific enzyme directly into the raw nectar. Step 2, this isn't just some instant reaction. It is actually a delayed release mechanism. The enzyme sits totally inactive until the honey begins to ripen in a watery environment. Step 3, once it's finally activated, this very enzyme deliberately produces both the hydrogen peroxide and gluconic acid.
But the engineering isn't just chemistry, right? It actually requires intense physical labor and pinpoint precision. Entomologist Dr. Eric Musson from the University of California explains that to get that second pillar of preservation, that thick consistency, the bees literally stand over the cells and furiously flap their wings. They do this specifically to evaporate the exact right amount of water. They are actively managing the moisture content.
And that brings us to the absolute, most crucial step of the whole process, the seal. This is an airtight beeswax cap placed over the hexagon cell, but here is the true genius of it. They only place this seal when the honey reaches the exact correct consistency. If the consistency is wrong, they wait. They just keep fanning. They only seal it with beeswax when it is absolutely perfect, effectively locking in a chemical state that is going to last for 3,000 years. When you put all of these steps together, it becomes really hard to look at a beehive simply as a nest. It basically begs us to look at it through a completely different lens.
Which brings us to Section 3, the factory metaphor. Because when you look at it, the everyday actions of this tiny insect perfectly mirror a highly advanced, automated human manufacturing facility. I mean, think about it. We take raw ingredients, the hive takes nectar. We use heavy machinery to process, they use wing flapping evaporation. We add chemical preservatives, they secrete a time-delayed enzyme. We have strict quality control inspections, they meticulously check the consistency. And finally, we use airtight packaging, perfectly mirrored by their airtight beeswax cap. Seeing this side-by-side comparison really forces a shift in how we process this information. We have to move from just a biological explanation into a deeper philosophical reflection.
So let's move into our final section, the hidden intelligence.
At this point, we really have to ask ourselves some pretty serious questions. I mean, did the bee somehow calculate this complex chemical engineering on its own? Does a tiny insect with a brain the size of a sesame seed really possess the cognitive capacity to invent an enzyme, understand delayed chemical activation, and deliberately manufacture antibacterial acid?
And furthermore, who taught the bee to run this highly coordinated, automated factory? How did this incredibly sophisticated, multi-step quality control process come to be programmed into a bug? If a human factory doesn't just build itself out of nowhere, how did the hive's perfectly optimized production line come to be? Now, what's really interesting is that the exact questions modern science is bringing up today were actually addressed a very long time ago. An answer provided 1,400 years ago points directly to a profound hidden intelligence behind this entire natural phenomenon. There is a perspective captured in an ancient text, specifically in the Quran, in a chapter literally called The Bee. It reads, "Your Lord inspired the bee. From its belly comes a drink of varying colors, in which there is healing for people." This ancient text directly attributes this biological marvel, this whole automated factory and complex engineering, to divine design and inspiration. What's really fascinating here is to just observe this historical alignment. On the left side, you have an ancient text from 1,400 years ago specifically claiming the substance contains healing for people. And on the right, you have modern science from 2022, hard data from Manchester and Toronto, empirically verifying those exact properties, everything from tissue regeneration to cardiometabolic benefits. And honestly, perhaps the most staggering fact of all of this is just the sheer scale of the operation. For millions of years, long before human history even began, every single day, generation after generation, the bee flawlessly executes this process. It adds the enzyme, it checks the consistency, it seals the perfectly engineered product. It is a cycle of relentless, unbroken perfection.
So, I want to leave you with a final thought to chew on. Next time you see a simple jar of honey, think about those ancient tombs. Think about the complex chemistry and the microscopic factory that made it. When we look at this 3,000-year-old edible superfood, are we really just looking at the lucky evolutionary work of a simple insect? Or, in the flawless execution of this design, are we witnessing the undeniable fingerprints of a master designer? I think it's a question well worth reflecting on. Thanks so much for joining me on this explainer, and as always, keep staying curious.